Okay, our next speaker almost requires no introduction whatsoever. No, he's that guy, whatever, so just this guy, you know. Andrew Godwin is a long-term member of the core team and purveyor of many fine products which you now use on a daily basis in the Django core. So I'd like to welcome to the stage, Andrew Godwin.
Thank you. Hello, everyone. Good afternoon. This slideshow deck is a little bit different to how it's going to be because my laptop is dead. So I have pulled this one from the internet from a previous talk, and I'm going to adjust it a little bit, but bear with me as we go. So I am, as mentioned, Andrew Godwin. I am perhaps most well known for doing South and Django migrations, which was my introduction into Django about a decade ago now, and was about 8 years of my time in Django before Marcus rescued it from me. In my real job, I am a software engineer at Eventbrite over in San Francisco, and I have a long history of doing sort of weird things with networking in Python. One of my first entries into serious Python programming on the networking side was writing Minecraft servers, back when Minecraft was but a small, young thing that people didn't really know about, and like this was this weird Java application. That is a tough thing to do when it gets popular in the space of a year, and suddenly your code is being used a lot. Who knew? But this talk is about not migrations. It's not about any of that stuff I used to do. It's about Django, HTTP, and WSGI, and the changing face of the web. I'm sure you're all aware that Django is very good at doing HTTP. That's what it was designed for a decade ago. It continues to do it very well. And it's designed around this core concept of taking a request and returning a response. Everything in Django, the middleware, the views, the URL routing, is built around this abstraction, right? Like when you run a middleware, there's a request and response handler. When you do a view, it's called by the request and it returns a response. And this is great. It nests really well. You have this wonderful diagram here of like, well, we have the browser and it calls the web server, which say gunicorn or mod WSGI, which then calls Django, which then calls the view. And it's a lovely like nested diagram, brilliant. It's turtles all the way down. We love it. And this works pretty well. Like HTTP matches this diagram, right? HTTP, you know, on an open socket, you can send a request. Then you have to just wait there as the browser and get a response. And you do this forever. If you pipeline, it can be one socket, but otherwise you open many sockets and it just sort of sits there by itself. If you are HTTP 2, the abstraction still holds pretty true. Now, there are other features, but the core feature of H2, which is the ability to have multiple requests in flight, you can still service this kind of thing with the same abstraction. You can just run two different functions in parallel for these two different requests. Where it breaks down is WebSockets. Now, if you're not familiar, WebSockets are a relatively new spec in the web space, but they are a way of having a bidirectional channel between a client, a browser, and a server. And what you can do is you can send things either direction over them at any time, in any order, without waiting for something else. Like you can send when it opens straight away. And they're good for things like chat applications and gaming and anything that's like a very chatty protocol. Previously, people used things like AJAX and long polling to get the same kind of effect. But WebSockets is much, much more efficient because each frame, each send or receive has a very small header and that's it. And it's designed to persist very well and work with a lot of the way browsers work. But the problem is, as you can see from this wonderfully colored diagram here, there is no send and receive pattern. We can't wrap it in the same way. And this is kind of difficult because WSGI, as an abstraction, is built on that callable pattern. WSGI is defined as there is a callable that you call with the request and it returns the response. It's a bit of extra stuff around it, but that's the core concept of what's going on here. So how do we tackle that problem with Django, right? We can't do WebSockets inside WSGI. It's not a possible thing. They just don't match this callable pattern. Even if you thought, well, we could have like generators to return things as the sends, well, how do you pass in multiple things as the inputs when you receive them? And so when I was looking at this problem about, I think, 4 years ago, I started thinking about this problem way back when WebSockets were being spec'd out. There were some things that I was thinking about, like, well, Django should probably support these. Like, this is the future of a lot of like the interactive web and the rich app web. But how do we do this in a Django way? And these are some of my sort of 5 main guiding lights for what it means to be a big feature in Django, at least right now. So first of all, easy to use. It shouldn't be a thing that says, oh, no, this is this great thing, and here is a 25-page long manual that's describing how to use it. Like Django is you load it up, you run a short tutorial, can't be super amazing to start with, and then it should be relatively obvious. And part of that is being secured by default. Django does its best to stop you shooting yourself in the foot. It's possible, but you have to sort of unpick certain different bits of Django very carefully to do that. And so it's important to have this thing where you can use it and you can intuitively play around with it, and it's very hard to deploy something that will blow up or be easy to DDoS and so on. And part of that too, when we're coming to network programming, is the extra problems of deadlocking. If you've ever written asynchronous Python code or even distributed systems code, deadlocking is a thing that happens, as is live locking. There's lots of different wonderful breakages that can happen. And making a system where it's very hard for a novice programmer or even a senior developer, because we're all terrible, to break things is really important. Like, I don't want to have a system where I can sleepily write code and break it. Deadlocks especially are very hard to debug, so trying to have a system where those are discouraged is very important. Python 2 and 3 compatible, of course. It's 2016. We can't quite do just 3 yet. That's Django 2, but getting there. And then finally, optional. And this is one of the most important parts of Django for me, is that a feature in Django, when it arrives, is optional. You're not forced to use it. You can replace it if you like, and it's usually cleanly defined. Things like, if you want to change templating, you can. Auth, you can. All these kind of things in Django are optional, and I don't want to have a system where I force everyone to use this crazy new thing because WebSockets, because let's be frank, a lot of people don't need them just yet. Maybe in the future, but right now we don't, and there's a balance to be had there. And so my main conclusion from this was, well, Python and its concurrency model is not the best. We have async IO in Python 3 and async and await and all the nice function keywords. But Django itself is not designed as an asynchronous framework. Django is fully synchronous. To rewrite it to be asynchronous would be to rewrite every single function we publicly expose, which would be moderately difficult, to say the least. And so looking at this and looking back at the history of languages like CSP, which was one of the very first proof languages for systems, and elements from that, things like Erlang and Go, the idea of message passing, the idea of different separate synchronous or asynchronous actor threads that swap messages between each other to achieve this sort of distributed system. And this is kind of what I was going for. So this is what we think out when we have a WSGI, a WSGI server and app. You have some servers or some processes. They run perfectly by themselves, standalone. HTTP is shared nothing, which is one of the, I think, personally, the most amazing things about it as a part of the web technology, that you can just launch as many of these as you like, and they'll just work independently. It's great. It's fantastic. No problem with that. Now, WebSocket's a bit harder. So if we naively approach the problem and go, well, we'll use the same model for WebSockets. We'll have a piece of code that just sits there and, like WSGI does, or Unicorn and MobWhiskey, handles talking WebSocket to the browser and decodes it into something inside Python. And then we'll have things talking to that handle the various bits of interacting with it. And so, we have the decoding part, we have some threads with workers in them. This all looks like a reasonable solution. There are 2 issues with this, however. The first is, of course, threads. If you use threads in Python, they are not the best. You can get away with 3 or 4 before they start getting too bad, but you don't want to run, say, 1,000 of them, because if someone opens 1,000 WebSocket connections, they can all sit idle for hours at a time. That's part of the protocol. And so you need the ability to be able to terminate thousands of things in a single process without having to have lots of threads. So green threads could be a thing here, but that's a different approach we take. But the other main thing here is what I call the real hard problem. So when people think about WebSockets, they go, well, we can take asynchronous frameworks, we can take libraries like Autobahn, we can join them together. We can get honestly, you can get a pretty good solution with the current libraries pretty quickly. It's actually not very difficult at all. But when you start looking at building a system, building a site out of these, you come into the real hard problem, which is that WebSockets, by their very nature and system design, are not shared nothing. You want to do things like this. You want to do, well, this is a chat application, and I have 6 browsers connected. I want to have one browser send a message and have all 6 of them receive it. And suddenly, you have to be able to pass this message from this entire server at the top here to the one at the bottom. And that is the problem that is really difficult to do. And that is kind of the problem that Channels aims to solve. Sure, it has WebSockets in there too, but it's in its totality is a system for designing Django to run more broadly distributed, to have this idea of passing messages between different things, have broadcasts and groups. And let's see a bit more of that in a more concrete fashion that isn't quite as hand-wavy. So before I do that, though, because important to how this works. How this works in practice. So I mentioned before threads and green threads. Channels eschews both of those for running things in separate processes, so like multiprocessing does. But rather than having a sort of in-memory queue like multiprocessing does between its different parent and child processes, what we do here is there is a formalized thing called a channel layer. And all the processes that Django comprises of, so like the terminating web server, which we call Daphne, the worker servers that run Django, these all just connect into the channel layer, which can be Redis, it can be IPC calls, it could be something like, it's a pluggable backend system. And the idea is that you run these different processes in different modes. So the terminating thing that handles like terminating WebSockets and doing the negotiation is asynchronous twisted code. It can handle thousands and thousands of connections at once on a single core because it has, it has a reactor-based pattern. It works perfectly fine. The Django side of this stuff runs in a different process in a synchronous loop. It basically it gets a message, processes it, returns the result, and then loops and runs it again. But because we have them in different processes, we can happily have these two different systems existing side by side. And what channels let you do is have this kind of pattern in general of you can write asynchronous code and tie it into your synchronous project without too much hassle and without giving up what synchronicity gives you from safety and easiness debugging. This can be extended a little bit. This is the more advanced version of this, where if you want to be better about performance, you go, well, Andrew, in this one, it's not hard to point out all the traffic goes through the big purple box in the middle, which is obviously bad for performance. But the design is such that we can actually have smaller purple boxes in the middle of the processes that do sort of, they know if they need to route outside. So it's kind of this encapsulation, but the point is all of this is handled for you. This is the hard problem. The idea is you can just talk to the channel layer from either side of what you're doing, and it will work out whether it can cache it locally, run it in process, send it across the network, and all this kind of stuff. So what are the concepts in channels? Like that's the theory. What does it come down to? Well, there's two key things in channels. There are the titular channels, which are named first in, first out queues. So it's a named thing. They all have string names, like this is my requests. And then you put things into them, and then they come out the other end. And in particular, they are a kind of queue where when multiple people request an item, only one of them gets it atomically. So the idea is you have like 7 or 8 worker processes listening. When a piece of work comes through, one of them gets it, and then the rest keep listening. This is kind of a bit like how Celery works in its basic structure, but there's some differences there in speed and guarantees. And the second one is groups. And groups is the part of here that's a hard problem. Groups are sets of channels of the thing at the top here that you can send to as a whole. And in particular, so say I had a chat room, whenever somebody connects to Django with WebSocket support now, you get a channel for them. And the channel is how you talk back to their browser. And what I can do is I can take all these reply channels and put them all into one group that is like my chat room. And then I can go, OK, a message came in, send to group the response. And every single person in that group gets distributed the message. And it does it efficiently. For example, in the Redis backend, it runs Lua inside Redis to actually farm it out rather than sending it to multiple lists. And what this comes down to after that is a pretty simple API. Now, as a Django developer, you'll probably never see this, but this talk is informative and enlightening, so here you go. And so this is what we call the ASGI, bad acronym I know, interface. This is how that central channel layer works. It provides these 5 primitives. You can send, you can receive. These are for channels. You can receive off many channels at once. So you put a big list in, and the first one that gets a response, you get that one back. And then you can add, remove, and send to groups. That's all you get. It's a very simple primitive list. It's very easy to program against. You can use it in any Python code, not just Django. So if you want to write your own custom stuff, you can. And then Django wraps this up into more of a nice, pretty picture. What it does is it takes this guarantee, where you take a request and return a response, and it turns it into a slightly different guarantee, where rather than a view that does what I just said, you have a thing called consumer, which takes a message on a channel and then sends 0 or more messages. And the nice thing about this, firstly, is that this is clearly a superset of what views do. A view is a consumer. And in fact, what channels can do, if you want it to, is it can map requests to a channel, it can map responses to another channel, and you can just do HTTP using the same system that WebSockets does. And in fact, internally, it actually is doing this when you install it. But crucially, also, when you do WebSockets, you can have things tied to events. Now, the way Channels handles protocols like WebSockets is it does eventing. So when someone connects, a message goes into a socket, onto a channel. When someone sends you a message goes onto a channel. When someone disconnects, it goes into the channel. And as a Django programmer, what you do is you write things that consume these channels, that when these events happen, you do something. So as I mentioned before, say you were doing a chat room. When someone connects, your consumer, you just write it in, you route it, you tie it in like a bit of a URLs thing and say, put this person in this group. When you have a receive message, you say, OK, take this message and send it to another WebSocket. And you can write this code much like you write views with the same kind of guarantees and the same sort of atomicity and transaction closing and all the stuff that requests come with and views, but for WebSockets as well. Let's get that slide, it's not important. Yeah, that one, there we go. So the difference here as well, like there's two different kinds of channels, which is important to know. Incoming channels, like WebSocket.receive, they are global. So every single person on your site who connects, when they send you a message, comes through the one channel called .receive. And your worker pool all listen on that channel, and when they get one, they take it off and run that handler. And so your consumer just handles any message from any connected person. You can add and remove servers as you like. It's very flexible. But then when you send something back to a socket, you can't have any server handle it. Because the WebSocket is terminated at a particular process on a particular box, when you send back to it, it has to route to that exact box. And so we have a bit of there's a naming convention there that Channels knows that if there's an exclamation mark in the name, it knows, OK, this has to go to a particular box. And it has different sharding algorithms to sort of distribute these differently. So briefly, we receive events from channels, and we send events to them in groups. And when you have a connection, be it WebSocket or HTTP, it comes to you into Django with a reply channel. That's how you reply to the person. HTTP, when you write to the reply channel, it writes a response. WebSocket, when you write to the channel, it sends them WebSocket frames. So let's see some actual practical examples, because that's a lot easier to understand. First of all, channels is very easy to use. It is not in Django yet, but you do this, then it just works, which is quite nice. You want to see what it does to Django under the hood? Just trust me that it's fine. It is doing less worse things than South. That I can guarantee you. But doing this will override your run server and a few other things, so that you can just do manage by run server, and run server will come with WebSocket support, and all the things I show you here will just work. So first of all, let's do a live blog. This is a very easy, classic first example of what goes on. We want a live blog, which, if you're not familiar, it's a blog with things dated by date, and then usually at a live event, like an Apple release, some journalist is on like a tether thing going, typing away randomly, hitting enter, and whenever a new thing comes through, it goes bonk and appears top of the page. The easy way to do this, the old way, is just poll for changes. Sit there going, is there a new one? Is there a new one? Yes, okay, load it. But that really hammers your server with requests, or it makes it very slow to load the new messages in. You have a trade-off there. So what we want to do is we want to open a socket when someone loads the page and go, OK, they've opened the live blog. Let's open a socket and just say, hey, tell me when a new blog post comes through. And the socket will just have things sent down whenever one comes through. And channels can do this very easily. So let's decompose that problem into what it means inside channels. So I said in channels, it's event-based. So what does it mean to do these things as part of the WebSocket event lifecycle? So when someone opens the page, they open WebSocket. We got that. And so when they connect, we want to add that socket to a group called live blog when they connect. And then when somebody saves a new model instance of blog post, we want to find the group and send a message to the group that then goes to all the connected sockets saying, there is a new blog post. So this is the entirety of the code. You define a connect handler like this. So this is what a handler looks like in channels. It looks like a view, obviously. It doesn't take a request, it takes a message, but it's very similar. And so on connect, we have a group. We add the reply channel to it. When someone saves, we just send to that group. And I've got here, oh no, and the one last thing here is you write a routing file, which is called routing.py, where it looks like urls.py. You go, websocket.connect is wsconnect, and it's done. And then you launch that up, and it will just work, which is super nice. And it's 5 extra lines of code. The chat one I mentioned earlier, let's go to that a little bit quickly as well. So again, let's look at the problem statement. People can send messages and they get sent, like, it's a chat. People send messages, everyone sees them. We all know how chats work. Let's take that as decomposed events. So when someone connects, they join a chat group, the group representing the room they're in. And when someone sends a message, we take the message and relay it back into the group again, so everyone who's connected sees it and receives it. And you can already imagine how this goes. We write two consumers, one for connect that adds them to the group, and one for receive that takes the message and just puts it and sends it back into the group again. And this is the very simple chat example. This will, again, we'll just do a chat room. That's all you need of the code word plus the routing. Oh, here's a routing example. There we go. I know I have one somewhere. So this is, routing looks like URLs. You say what the channel name is. You just put the function in. It happens. It's pretty easy. So important notes. These are a bit old, but I'll go through some other stuff. So run server, as I mentioned, just works with WebSockets. Like you can do this code and just do manage by run server. It will just run properly. It does a lot of different stuff under the hood, but you don't need to worry about that. It's not too bad. Django sessions and auth work with WebSockets. There is code in channels that can take the cookie you have on your site and load it out of the connection header of WebSockets and have the authentication on the socket permanently. So you can actually do assertions and people use people's usernames and values and permissions inside socket handlers for free natively. It works pretty well. There are class-based consumers. So these are function-based consumers. There is, like for views, a class-based version too. And that has things like group management come for free in that one. You can say, oh, connection groups equals chat, and it will handle the connect to disconnect stuff for you. But most importantly, these two things I rushed through kind of quickly. There are fully worked versions of these with lots of comments, lots more features, and fun tasks to do at this GitHub repository, Andrew Godwin /channels examples. There's also another example there for data binding, which I introduced at DjangoCon US a few weeks ago. But I believe in proof by both talks and there's documentation and examples. Whatever one you want, you can pick the right one. But you can download these, just install channels, and then just run server, and you'll have, there's a multi-room chat app with authentication in it, just to prove how that stuff works. And there is a live blog that has multiple live blogs with like slug-based differentials. Like you have, oh, here's our Apple live blog, here's our Google live blog, and they can run at the same time. So sort of more in-depth versions of those with comments explaining what I'm doing going on there. And so hopefully that gave you a bit of an idea of the flavor of what's going on here. We have channels, we have groups, and we have these messages. And the messages are kind of part of the magic. WSGI defines how you map HTTP into, in this case, in the case of WSGI, a dictionary called environ and a way to send headers back. What ASGI does, it defines the same thing for WebSockets and also HTTP of like, here's how we encode HTTP and sockets into messages, which are just dictionaries, basically, and how we can have those formats for sending and receiving messages over the wire. And crucially, all of this is cross-process and cross-network. You can take all of this stuff and just go, well, I'll have this on this machine, this on this machine, this over here, and it will just work. You can scale out the front end separately from the workers based on your kind of workload. And the whole idea is this is designed to overcome Python's limitation of being a single-threaded, like, it's very good at single threading and not very good at anything else. So say, well, okay, we can work with that. We can just have single threads and just join them across a network. Because even if you're doing multi-threading, you have to go cross-machine at some point. So why not just do it from the get-go? And so, as I said, their spec that underlies all channels is called ASGI in a fit of maybe poor naming of my part, but it's too late now. And so what this comprises of is that specification for how you send and receive groups, those 5 functions from earlier, and these formats for HTTP. And the idea is, given this specification, like WSGI, you can write a server that just publishes WebSocket into the spec. Like, as long as you send messages according to the spec and receive them and decode them properly, it will just do the right thing. And similarly, as an application, you can write something against the end of it. So Django obviously is written against this, but one could have, say, Flask written against this too, if you wanted to do the same kind of consuming. And as for what that transport is, there are currently 3 of them. There is the reference network layer, which is Redis-based. There are many reasons for Redis. I can go into them at length if you come and ask me. We are looking at trying to get a RabbitMQ/AMQP one, but it is, AMQP is not designed for low latency, let's say. It's not designed for high throughput either. There is a POSIX IPC one, which is not cross-network, but works on one machine with no extra dependencies. So like Redis, you've got to run a server. IPC, you just run them on the same machine, and they just make a shared memory segment and talk to each other using dark Unix magic. And then in memory, it's just one for testing. It just exists in memory. And then what this all means is that all of these things work together to form a Django project. Like, no longer is Django running as a separate thing. You now have these separate servers that do decoding of HTTP and WebSockets, and separate servers that run the actual application code. And this is kind of broken down into what it looks like in terms of packages. So Channels has a few packages. There's quite a few of them. But on the interface side, Daphne is our reference server that does both HTTP and WebSockets. It's based on Twisted and Autobahn. But as I said before, other stuff can plug into there. And there's also an in-progress WSGI adapter that just is a WSGI app that then itself makes things into ASGI. So it's kind of a translation part of that end of the spectrum. So you can just actually run this behind Unicorn and ModWhiskey if you want to. In the middle, you have different channel layers you get to choose from. The idea is we'll have more than two based on people's differences or their requirements or their kind of runtime environment. And on the worker side, again, Django is one consumer, but there's also potential here to write a WSGI adapter the other way, where something receives ASGI stuff and then actually runs a WSGI application underneath. And so like, it's meant to be intercompatible with this sort of existing apps as well. And also, like, as I said, optionality is very important to me. So you can run everything through this system, or you can just do WebSockets through the system and use the old stuff for the HTTP. It's your choice. And most people just run WebSocket through for now, because like, you can do like long polling stuff really well in Channels with the new server, but it doesn't give you much else over WSGI right now if you're doing just HTTP. Let's skip that one. So yeah, scaling. Because of this network layer, you can actually scale the things that terminate connections separately from the things that run code. So if you have a very dormant set of people who've got lots of connections, you can scale that very differently. If there's very few people but they run lots of very expensive stuff, you can scale the workers out. The channel layer itself, the Redis one has like consistent hash-based sharding if you want that kind of stuff in the middle. So it works pretty well. There we go. There we are. So looking ahead, Channels missed Django 1.10. It may go in 1.11, but that is an LTS release, so I am not entirely sure about that because I want to have a nice stable platform for the future. So there's a good chance it may be in 2.0, or maybe it will stay external forever. Like, one of the questions now is, do we take Django and make it more separate? Like, the core has wanted to for a while, keep things a bit more separate. But one of the things I am going for is becoming an official external app. So we have a dep now for official Django apps that are not actually core Django, and keeping the same security policy and stuff in place. And so I'm going to try and bring Channels under that process and bring it under Django GitHub organization and all that kind of stuff pretty soon. Maturity, obviously, I can't just come and say, oh, run my crazy code that Andrew wrote that's based on stuff. People who run ops systems will not trust me on that, and I believe them very well for doing this. But part of this is a long road. Like, the key part of Channels is we start a year ago. It takes 3 or 4 years to get to full trustability in this stuff. But right now, people are running it in production. It has been fine. I've got one bug report that we fixed within 3 hours, and it wasn't really that bad. And the load tests we're doing seem pretty good. Like, load tested wise, it runs about the same as, say, Unicorn would do on a default configuration. So it's certainly it's not worse, which is quite nice. Community, the idea of Channels is it is a base set of tools that is to be built upon. It's not meant to be a full solved problem of how to do everything in WebSockets. And the idea is we'll have a community of third-party tools and extensions and work around Channels to sort of enhance the experience. As one example, some people are interested in managing like exact how many people are connected right now and like connected and alive with like live pinging. That's the sort of thing that we could do as a sort of third-party app that plugs into the ecosystem pretty well. Coexistence. Not all of you need the WebSockets, and that's fine. And the whole point of Channels is that it's optional. It's easy to add, easy to remove. You don't have to run anything on it if you don't want to. It's just a thing. If you want it, it's there. Expansion. It's not just WebSockets. Like, the whole point of this sort of crazy thing with all the arrows and diagrams is that it expands beyond WebSockets. You can use it for emails, you can use it for chat, other message formats. It's flexible. And because it's an event-based system, you can extend it to lots more stuff other than sockets. Just that WebSockets are the thing that are the most pressing sort of concern of the modern web. And then finally, specification. ASGI is not Django specific. My goal is some kind of cross-Python spec that lets us do WebSockets across different things in Python rather than just in Django. But it's a while before I reach the point that I can take it to something like WebSig and say, like, start discussing formally, what does it mean for us to support WebSockets in a world of Python 3 and async and await. And the spec is not quite there yet for that, but getting close. If you're interested in more, there is a lot of documentation on the documentation site. There are examples, as I said before, and I really hope that you enjoy it. Thank you very much.